Namaskaram everyone. Welcome back for mathematics webinar of today. Mathematics 1B, straight lines. 2 lessons have already been completed. Students, I hope and I'm sure you must have made a note of all the important points and also applied those points and solved all the questions that were given as practice session as well as the questions given in the textbook. Now, today we have our own Saishwari ma'am, who is really taking out time to make it possible for you all to learn straight lines in the proper way. And madam is here with lesson 3 of straight lines. I take this privilege of welcoming once again Mrs. M.SAI, Principal of TSMS Munagala, Suryapet District, to continue the session 3 of straight lines and help you all learn it in a better way. Over to you, ma'am.
Thank you, ma'am. Thank you so much. That was so nice of you. Good morning to all the viewers. Hope you have been getting a lot of information regarding your classes. And now the webinars are extended to 4 sessions. So I think you can utilize maximum now. Right. So today we are going to go with lesson 3. I hope you have watched lesson 1 and 2. So let me just quickly recap with what we have learned in lesson 1 and 2. So what exactly is going to be there in our plate today? So here, what are we going to learn today? Today we are going to recap lessons 1 and 2. And then go ahead with the next topic, intersection of 2 straight lines. Then we are going to learn about half planes. Then finally, we will conclude with family of straight lines, which are concurrent lines. So this is what we are going to learn today. Now here, let us recap with the previous knowledge, what we have learned. Hope children, you remember So sorry for the short interruption. There was a transmission problem from my side. Yeah, we were talking about the definition of slope of a straight line. Now, the next thing that we have seen was about the different forms of the straight line. We have seen the standard form ax plus by plus c equal to 0, slope intercept form, normal form, symmetric form, 2-point form, and point slope form. This is what the different forms we have seen in lesson 2. We also have seen the different conversions of the standard form into other forms also. So you could watch lesson 2 if you want more about the conversions. Now let us go into the next topic, which is intersection of two straight lines. Now this is nothing new to you. You have already been learning this in your previous classes also. If there are two lines, L1 and L2, which are intersecting at a point P, and the equations of the lines are given by a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0. These two are intersecting at the point P of x naught to y naught. Then how do we find P? See, there are two different methods. Obviously, these are two linear lines. So you can simply solve this pair of lines which you have learnt in your 10th class. Even you have drawn graphs to solve these equations. So here we have another method, that is we directly substitute in this formula. So to get the point of intersection, we use this formula b1c2 minus b2c1 by a1b2 minus a2b1 and c1a2 minus c2a1 by a1b2 minus a2b1. This is the formula to find the point of intersection of two straight lines. Now, how do we get this? So here we go with the theorem, where the theorem says if L1 is a1x plus b1y plus c1 equal to 0, and L2 is a2x plus b2y plus c2 equal to 0, represent two intersecting lines, then their point of intersection is this particular point here. b1c2 minus b2c1 by a1b2 minus a2b1, comma c1a2 minus c2a1 by a1b2 minus a2b1. Now this looks little cumbersome to you. So let me try to make it easy. So how do we get this? Let us first see the proof. Then you will actually understand how you got the point. Now here, consider the straight lines L1 as equation 1 and L2 as equation 2. Now, the point of intersection P of x naught y naught obviously lies on both these lines, isn't it? The point definitely lies on L1 as well as on L2. So which means definitely this x naught y naught will satisfy the first line L1 and also the second line L2. Now let us substitute x naught to y naught in equations 1 and 2, and we get the equations 3 and 4 like this. Now let us try to solve. Now we are going to use here a method called cross multiplication method, which you must have learnt in your 10th class while learning the topic pair of linear equations. Now here, what is this cross multiplication? Take the coefficients of the first line, starting with the quotient of y. As you can see in the previous slide, the line is a1x plus b1y plus c1. Now what I'm going to do, I'm going to start with this b1, then go with this c1, then a1, again repeat b1. Now you can see, we are going to start with the quotient of y, constant, x, and again y. Repeat the process to the second line also. Now, how are we going to use this cross multiplication? This is how we are going to use. Multiply b1 with c2 and subtract b2 c1 from it. So b1 c2 minus b2 c1. That becomes the numerator of the x coordinate. Now the next product, c1a2 minus c2a1. As you can see in the next line, c1a2 minus c2a1 becomes the numerator of the y coordinate. Okay, so this is how simply we can remember the formula instead of making the cumbersome formula that is seen previously. Now the denominators is the cross product of the last one, which is A1 B2 minus A2 B1. So children, what is that you have to do? First of all, write the coefficients of y constant, x and y again of the first line, and y constant, x and y again of the second line. Now go with the cross multiplication b1 c2 minus b2 c1, which gives you the numerator of x coordinate. Similarly, C1A2 minus C2A1 becomes the y coordinate numerator. Now, both the denominators are given by the last cross product, which is A1B2 minus A2B1. So, this is how we get the point of intersection P of x naught y naught, which is the point of intersection of the two lines L1 and L2. Now, let us use this formula and find out a problem. Here, we are going to find the point of intersection of the two lines 4x plus 8y minus 1 equal to 0 and 2x minus y plus 1 equal to 0. Now here take both the lines and compare these lines with the standard form. Now here as you can see, if 4x plus 8y minus 1 equal to 0 is compared with a1x plus b1y plus c1 equal to 0, obviously in the place of a1 we have got 4, b1 is 8, C1 is minus 1, A2 is 2, B2 is minus 1, and C2 is 1. Now, after comparing these coefficients, all that you have to do is simply substitute in the formula. Okay, now how are we going to substitute? The substitution in this part can also be done with the cross multiplication method, which I have shown you in the previous slide. Simply start with B1. So B1, C1, A1, B1. That is 8 minus 1, 4 minus 1, 8 again. Now for the second line, B2, C2, A2, B2. So minus 1, 1, 2, and again minus 1. Now the numerator is just the cross product 8 into 1 minus of minus 1 into minus 1. This is the numerator of the x coordinate. Now the next product, minus 1 into 2, you can see here, minus 1 into 2, minus 4 into 1. This is the numerator of the y coordinate. Now what about the denominators? 4 into minus 1, minus 8 into 2. This is the denominator of both the coordinates. This is how the cross multiplication can be done in order to avoid errors. It is very common that we all go with errors in mathematics. Substitution part, if you do it right, you get the problem right. So while doing the substitution, if you do this cross multiplication method, it would be easy for you and you will not go wrong anywhere. And it will be faster also, especially while you're calculating in your M.SAI, where you are given only 50 seconds per bit. There it helps you a lot. Now on simplification, as you can see, 8 ones are 8. Minus of minus 1 into minus 1 gives us minus 1. And denominator is minus 4 minus 16. Similarly here, this is minus 2 minus 4 by minus 4 minus 16. Now here 8 minus 1, here is 7. Minus 4 minus 16 becomes minus 20. Here minus 2 minus 4 becomes minus 6. And minus 4 minus 16 becomes minus 20. So this is how we can find the point of intersection of two lines which are given in the standard form. Of course, you also have the second method where simply you can take the equations and solve them using pair of linear equations method. There also you will get the same value. So either way you can get the point of intersection. So next we go with the concept of half planes. Now half plane, the very name itself is suggesting you. What is that half? See, any plane. See here I have taken a rectangle. Actually the screen itself is a plane. The wall might be a plane. A plane is a plane anywhere. So it is not just confined to one particular rectangle. Here I am taking an example as a rectangle where a plane is taken and the line, any straight line, will divide this half plane into three different sections. Now you can see only two parts here, right? What are the three different sections? You can see the blue part and the yellow part. Only two. But what are these three? Now here we are talking about the points on the parts. We are going to take the plane which is divided by the straight line in three parts. How? The first part are the set of points on the straight line, which are here A, B, C, and D. And the second set are the points on one side of the plane, which are E, F, G, and H. And points on the other side of the straight line, which are P, Q, R, and S. So here we have three sets of points. The set of points on the straight line, the set of points on one half of the straight line, and the set of points on the other side of the straight line. Now, how do we identify this? Suppose you are given the straight line and a point. Now, how do you identify whether the point is on the line or on one side of the line or on the other side? How do we get this? Here we go. So here the concept is, suppose the plane is divided by the straight line L equal to 0, which is given in the standard form ax plus by plus c is equal to 0. Then we have, briefly, let us write that ax plus by plus c equal to 0 as L equal to 0. Okay. If every time, wherever you see L equal to 0, students, please remember it is a standard form ax plus by plus c equal to 0. Now we have set of points on the line, which are A, B, C, D, which you know will satisfy the equation L equal to 0. So for all these A, B, C, D, you will get L, the value of L as 0 on substitution of that point in the standard form. Now what will happen to the set of points on one side? On one side of the plane, if you substitute these points in the equation L equal to 0, you will get L greater than 0. Now, if L is greater than 0, that is positive, then you will understand that that set of points are on one side of the plane. Now, if you take on either side, suppose you are taking the point on either side, then the value of L will be negative. So here you have to remember that if L is equal to 0 on substitution of the points, then the point lies on the line. If L is greater than 0, it lies on one side of the plane. If L is less than 0, it lies on other side of the plane. Now here, let us learn some notations because all the time it may not be possible to write the equations. So here the notation is, if you substitute x1, y1, the equation becomes ax1 plus by1 plus c, which we are going to denote it as L11. So what does L11 mean? L11 is simply substitution of x1, y1 in the standard form, which you will get it as ax1 plus by1 plus c. Now, what is L22? L22 is nothing but substitution of the point P of x2, y2 on the line ax plus by plus c, which is ax2 plus by2 plus c. So please remember L11, substitution of x1, y1, L22, substitution of the point x2, y2. Now here, what are we going to do with these points? We are going to see whether if 2 points are given to us, those 2 points, whether they are on both sides of the line or are they on the same side of the line. So this will help you to understand where the points are geometrically. Okay. So here, this theorem tells us that the ratio in which the straight line L ax plus by plus c equal to 0 divides the line segment joining the points ax1, y1 and bx2, y2 is minus L11 is to L22. So here we are going to understand the ratio in which a line divides another line which is joining 2 points. Hope you remember in your 10th class you must have learned section formula where you will understand the ratio in which a particular point divides a line segment joining 2 points. Here we are talking about the ratio divided by a line joining another 2 points. Okay. So here we have a line segment which is joined by the 2 points A x1 y1 and B x2 y2, which is now intersected by the line L equal to 0, which is in the standard form. Now the ratio in which it divides is minus L11 is to L22. How do we get this? Now let us take the point of intersection as P. Now, as per the section formula which you have learnt in your 10th class, P, suppose I take it as x naught, y naught, it divides in the ratio L is to M, and this L is to M is brought by P is equal to Lx2 plus Mx1 by L plus M, and Ly2 plus My1 by L plus M. This is from your 10th class formula. Now you understand that this point P lies on the line L, is it not? Now, if it is lying on the line L, definitely this point has to satisfy the equation L equal to 0. That means on substitution of this point on the line, you will get A Lx2 plus Mx1 by L plus M plus B Ly2 plus My1 by L plus M plus C equal to 0. Now, taking this L plus M as the LCM throughout, you will get this particular equation where A Lx2 plus Mx1 plus B Ly2 plus My1 plus C into L plus M is equal to 0. Now, here, if I take L and M common, I would be getting L is to M ratio as this one. So L is to M is minus AX1 plus BY1 plus C is to AX2 plus BY2 plus C, which is nothing but minus L11 is to L22 as per our notation. So here what is that you have to understand? Here we have to understand that the line segment AB bar is divided by the line L in the ratio L is to M, which is given by minus L11 is to L22. Now, if the ratio is positive, so after substituting these points in the line, after all, we'll get a ratio, is it not? If that ratio is positive, we understand that those 2 points are on either side of the line. They're on the opposite sides. So here what do we understand? The points A, B are on opposite sides of the line L equal to 0, which means P divides AB bar internally, which means L is to M is going to be positive. Minus L11 is to L22 is going to be greater than 0, which means L11 and L22 have opposite signs. So the ratios are of opposite signs. If one is positive, the other one is negative. The first one is negative, second one is positive. Now the other way around is also true. If the ratio have opposite signs, then L is to M is positive. If it is positive, P divides internally. If it divides internally, then A, B lie on opposite sides of L equal to 0. So this is one tip you can remember for your competitive exams, where if the ratio is positive, then the points are on opposite sides. So obviously now I think you can guess the next slide. The next slide is if the points are on opposite sides and they are externally divided, then obviously you have same sign. So here L11, L22 have same sign, which means A, B are on the same side. Now here we also can extend this ratio to what happens if x-axis divides AB bar. And what ratio will x-axis divide AB bar? It is simply nothing but the ratio between their y coordinates, which is y1 is to y2. Of course, minus y1 is to y2. Similarly, we can also see that if the line segment is intersected by y-axis, then the y-axis will divide the line segment joining x1, y1 in the ratio of their x coordinates with a minus sign. So y-axis divides AB bar in the ratio minus x1 is to x2. So this will also help in your competitive exams. Please remember, x-axis divides AB in the ratio minus y1 is to y2, and y-axis divides AB in the ratio minus x1 is to x2. Now let us see an example where how exactly are this formula used? Now here we are asked to find the ratio in which the straight line 2x plus 3y minus 20 equal to 0 divides the join of the points 2 comma 3 and 2 comma 10. Now take the straight line L equal to 2x plus 3y minus 20 equal to 0. All that you have to do is substitute first point in the first line and the second point also in L. On substituting 2 comma 3, I will get L11, which is 2 into 2 plus 3 into 3 minus 20. This is 4 plus 9. 4 plus 9 is 13. 13 minus 20 is minus 7. Similarly, substitute the second point 2 comma 10 in the line. It is 2 2s are 4 plus 3 into 10, 30 minus 20. So 4 plus 30, 34 minus 20 gives us 14. So the straight line L equal to 0 divides the given line segment in the ratio minus L11 is to L22, which is minus 7 is to minus of minus 7 is to 14, which is greater than 0. And so the division is internal. So here by seeing this L11 and L22 itself, you can tell they are of opposite signs. If they are of opposite signs, then both the points will lie on both the sides, on either side of the line. That is, P will be in between A and B. So P divides internally. That's what you can tell. Okay. Simply by looking into L11 and L22, you can first conclude number one, A and B lie on either side. Number two, P divides the line segment internally. So these two things can be understood. Now, here, let us see another example. Find the ratios in which the x-axis and the y-axis divide the line segment AB joining A 2 comma minus 3 and B, which is 3 comma minus 6. Okay, so here x-axis divides AB in the ratio minus y1 is to y2. It is simply the ratio of the y coordinates. So it is minus y1, which is minus of minus 3 plus 3 is to minus 6, which ultimately gives us minus 1 is to 2. So here again the ratio is negative. So the ratio is negative. What do we understand? Again, we understand they lie on both the sides. Now, again, another second part is given. The y-axis divides AB in the ratio minus x1 is to x2. So here x1 is 2. So minus 2 is to x2 is 3. So the ratio in which y-axis divides is minus 2 is to 3. And so again we understand that both the axes of the coordinates divide the line segment AB externally. So here, this is what the next concept is. We're going to take family of straight lines now. It is not one simple line. We have learned enough about one line. Now let us learn about the family of lines. If we have more than two lines, what is happening? If two lines are there, just we have seen how they intersect, how they make a ratio. Now let us see the family of straight lines. They're also called as concurrent lines, which already you have a concept in your previous classes, somewhere in your 7th or 8th classes you must have learned. Now the concurrent lines are what? When three or more lines intersect one another at a single point, then they are said to be concurrent lines. So here you can see this P of x1, y1, which is the point of intersection of all these lines. So this is also representing our India. We are of different religions, caste, creed, everything. But one point which is concurrent to all of us is that we are Indians. See, mathematics teaches you a lot of philosophy. So this is one point, the concurrent lines teaches you whether you belong to any state, any caste, any religion. We are all concurrent at one point, that is, we are Indians. So here, the concurrent lines means when three or more lines intersect one another at a single point, then they are said to be concurrent lines. So there are lines which are intersecting at one point. So here, how to find this? So it is simple as simply taking those lines and finding the point of intersection. But here we have a concept. there is a statement which says that if L1 is A1x plus B1y plus C1 equal to 0 and L2 is A2x plus B2y plus C2 equal to 0 represent two intersecting lines, then the equation lambda 1 L1 plus lambda 2 L2 is equal to 0, for which the parametric values of lambda 1 and lambda 2 with lambda 1 square plus lambda 2 square not equal to 0 represents a family of straight lines passing through the point of intersection P of x1, y1. See, this is one concept that you will again get in your topic called vectors. So the vectors topic also, the same concept will repeat for you in a different way, where you will find the equation of straight lines are of this form. Anyway, for now, lambda 1, lambda 2 are two real numbers which connect all these lines. So what is that you have to remember? We have to remember that any equation in this form, that is lambda 1 L1 plus lambda 2 L2 equal to 0, represents family of straight lines. You keep changing the values of lambda 1, lambda 2, you will be getting each line each time. So this is what conversely said. We are also conversely said that the equation of any straight line passing to the point of intersection of the given straight lines is of the form lambda 1 L1 plus lambda 2 L2 equal to 0 for real values of lambda 1 and lambda 2, such that lambda 1 square plus lambda 2 square is not equal to 0, represents a family of straight lines. See, so here what do we understand? We understand that both ways are true. That is, if there are lines called L1, L2, they will be connected with some real coefficients called lambda 1, lambda 2 as lambda 1, L1 plus lambda 2, L2. You can extend that lambda 3, L3 and so on. And the converse is true. If there is a line which is connected by these real values, lambda 1, L1 plus lambda 2, L2, obviously we can say that L1, L2 represent family of straight lines. So they all meet at a point. That is what we understand. Okay. So here, now what is the difference between concurrent lines and intersecting lines? Firstly, we have seen intersecting lines and their point of intersection. Now we are talking about concurrent lines which meet at a point or they intersect at a common point. Now here, what is the difference? If any three lines or line segments or rays are having a single intersection point, they are said to be in concurrency. While in the case of intersecting lines, there are only two line segments or rays that intersect with each other. I hope you understand the definition. Just let us see in the tabular form. I've just put it in the tabular form. So, concurrent lines, three or more lines pass through a single point. Intersecting lines, only two lines intersect each other. Here, the single point at which these lines intersect each other is called point of concurrency. Here, the point where two lines intersect is called point of intersection. See, whatever it is, here you're going to have more than two lines. Here, you're going to have two lines. Here it is called point of intersection. Here it is called point of concurrency. Here we say intersection. Here we call it as concurrent. Okay. So this is how the concurrent lines will look like. And this is how two intersecting lines are going to look like. Ultimately, it is same. They're all going to meet at one point. Two lines, intersecting lines. More than two, more than three, concurrent lines. That is what is the difference. So here, what is the condition for concurrent lines? See, I am given three lines. One line, L1 like this, A1x plus B1y plus C1 equal to 0. L2, A2x plus B2y plus C2 equal to 0. Then another line I have got L3 which is A3x plus B3y plus C3 equal to 0. Now here, these three lines are given to us, L1, L2, L3, be three straight lines, no two of which are parallel. Then these lines are concurrent if and only if A1 into B2 C3 minus B3 C2 plus B1 into C2 A3 minus C3 A2 plus C1 into A2 B3 minus A3 B2 is equal to 0. If you remember, this is something like area of your triangle. Okay. So if you also remember, we will use that condition for collinearity also. But here, these are the coefficients of these lines which all meet at one point, and no two of which are parallel. Now, how do we get this? We simply get by solving 1 and 2. See, it is as simple as solving two equations and substituting that point in the third line, which I'm just skipping off because it's very simple to understand, and it doesn't require much note here. So what is that you have to note down? See, the above condition, see, A1 into B2, C3, B3, C2, it is looking little bit lengthy for us to remember. Is it not? So in the competitive exams, especially when you go for your MSET on IIT, JEE, or even our regular IP, it gives you a faster form. See, you people are all fast enough to learn things. So here we want a fast answer. So how do you get this fast answer? You will learn this in your uh, 1 year topic called determinants. Once you know how to find a determinant, simply you have to do what? You have to find the determinant of the coefficients. And how are we placing them? See, this A1, A2, A3, which are the coefficients of X on the first column, coefficients of Y in the second column, and the coefficients of and the constants in the third column. You place like this in the matrix and you find what is called determinant. You will learn more about determinants in your 1 year session. There are a lot of applications for this determinants, and this is one best example of usage of determinants. Just define the depth of the coefficients of the given lines. And if you get the determinant 0, you will obviously say that all these three lines are concurrent. And if the determinant is not 0, I need not tell you, they are not concurrent. Okay. Now here, let us see how we can transform this. The problem here is transform the following equation into the form L1 plus lambda L2 equal to 0 and find the point of concurrency of the family of straight lines represented by the equation 2 plus 5k into x minus 3 into 1 plus 2k into y plus 2 minus k equal to 0. This is picked from the exercise problem. So here, this is something like a family of straight lines which has got constants, and we are asked to convert this form into L1 plus lambda L2 equal to 0. And in the place of lambda, here we are given a constant called k. Let us see how we can solve this. So here we have taken the given equation as it is. 2 plus 5k into x minus 3 into 1 plus 2k into y plus 2 minus k equal to 0. And here we have opened up all the brackets, multiply this by x, 2x plus 5kx minus 3 into 1 into y minus 3y minus 3 into 2k into y minus 6ky plus 2 minus k equal to 0. Now here, let us separate the terms with k and without k. Now here 2x doesn't have k. I've put it in the front. Next we have minus 3y, which also doesn't have k. So I pulled it to the second term. Then we have plus 2, a constant, which also doesn't have k. Now this portion, 2x minus 3y plus 2, represent one particular line. Now the other three terms that I have left here can be taken with a k common. Suppose I take k common, we will get 5x minus 6y minus 1. Now this is in the form of L1 plus lambda L2 equal to 0, which we have seen in the theorem. And in the place of lambda, we have got a constant called k. So in this form, we can understand that the first part 2x minus 3y plus 2 represents one line, and 5x minus 6y minus 1 represents second line. Okay, children? So this is how you can separate and show. Now, what is the next part that is asked? We're also asked to find the point of concurrency. Point of concurrency means what? It is simply the point of intersection. And to find the point of intersection, already we have seen in the intersection of straight lines, this formula B1C2 minus B2C1 by A1B2 minus A2B1. C1 A2 minus C2 A1 by A1 B2 minus A2 B1. You can see here A1 is 2, B1 is minus 3, C1 is 2, A2 is 5, B2 is minus 6, and C2 is minus 1. So using these coefficients, we can substitute in this formula and try to simplify. On simplification, we get the point of intersection as 5, comma 4. Now even you can simply solve these lines to cancel it Q of 3, angle 3 pi by 4 with the negative direction of x-axis. If the straight line intersects the line x plus y minus 7 equal to 0 at P, then you have to find the distance between P and Q. So what are we given? We are given that there is a line which is passing through Q of 2, comma 3 and is making an angle 3 pi by 4. Direction of the x-axis. Now what we have learned in slope, we have learned that slope means an angle made in the positive direction. Now if it is making negative direction, what is that we have to do? See, this is the negative direction 3 by 4. So what is it in the positive direction? The positive direction will be 180 minus this particular angle. So here the slope will be m equal to tan of pi minus 3 pi by 4, which is tan pi by 4. And you know tan pi by 4 is tan 45, which is 1. So I got the slope m equal to 1. And a point on the line L is given in the problem itself. The straight line is passing through Q of 2, comma 3. So we have got a point and a slope. And I hope you remember, if you know the point and the slope, what is the form we are going to use? You can guess the next line. Yes, is it not? It is simply the point slope form y minus y1 is equal to m into x minus x, where here the point is Q of 2, comma 3 and the slope is 1. On simple substitution of these points in the equation, we get x minus y plus 1 equal to 0. So now this is the line which is passing through a Q and making a angle 3 pi by 4 in the negative direction. This line is intersecting with another line called x plus y minus 7 equal to 0. So we have to find the point of intersection, is it not? So now the choice is yours. You can either solve these two lines using your elimination process, which you have learned in your 10th class, or use the formula B1C2 minus B2C1 by A1 B2 minus A2 B1, either of it. See, the lines are simple, very simple. By simply adding these two lines, x minus y plus 1 equal to 0 and x plus y minus 7 equal to 0, y will get cancelled. You will have x plus x, 2x. 2x minus 6 equal to 0, or 2x equal to 6, or x equal to 3. Similarly, if you subtract these equations, you will get the value of y as 4. So here the point of intersection of these two lines is P of 3, comma 4. So our aim here is to find the distance between these 2 points. Now here we are going to use distance formula. I hope you remember from your 10th class as well as in your previous classes. While doing locus also, you have used this formula. What is the formula for distance? Yes, it is PQ equal to under root y2 minus y1 whole square plus x2 minus x1 whole square. So here x2 minus x1 whole square gives me 2 minus 3 whole square. Y2 minus y1 gives me 3 minus 4 whole square. And on simplification, we get the value of PQ as root 2. This is how you can find the distance between the 2 points, where one point lies on the line which is making a negative angle 3 pi by 4 with x-axis, and another point is on that line. Now let us see one more problem where you have to find the value of k if given lines are concurrent. So here we are given 3 lines L1, L2, L3, and they are given concurrent. We have to find the value of k. So I have taken the 3 lines whose equations are given, and applying cross multiplication method. I hope you remember the cross multiplication method. You have to take the coefficient of y, then constant, then x, then again y, and apply cross multiplication. You will get this value as 3 into 13. Yes, you can take the cross multiplication values and you get x by 132 minus 143 is equal to y by minus 104 plus 99 is equal to 1 by minus 33 plus 32. On substituting these values, you will get the value of k. Yeah. So this is a, you can solve for k and get the value. So this gives us x equal to 11 and y equal to 5. And on substitution of this x equal to 11 and y equal to 5 in the first line, you will get the value of k as minus 7. Now let us see one more problem which is quite commonly given for all kinds of exams. If the straight lines ax plus by plus c equal to 0, bx plus cy plus a equal to 0, and cx plus ay plus b equal to 0 are concurrent, then you have to prove that aq plus bq plus ck is equal to 3abc. Now let us take all the three lines. Now you can use cross product method here. See, this is AB minus C square by y into BC minus A square. Then again AC minus B square. So on substitution, you will get the point of intersection of L1 and L2. A minus C square by CA minus B square, BC minus A square by CA minus B square. Now, these three lines are concurrent. We understand that this point satisfies the third line also. So substituting this point in the third line and simplifying it, we will get AQ plus BQ plus CQ is equal to 3ABC. Now here is another important problem. Now here what is said. A triangle of area 24 square units is formed by a straight line and the coordinate axis in the first quadrant. Now we have to find the equation of the straight line if it passes through 3, 4. Now when it is intersecting the coordinate axis, it is quite common or quite easy to take the intercept form, which will help you to calculate faster. So if let me take the intercept form of the straight line x by a plus y by b equal to 1. But here we have said that this 3, 4 passes through the line. So in the place of x and y, simply substitute 3 and 4. That is 3 by a plus 4 by b equal to 1. Now the area of triangle AOB is 24, which is given in the hypothesis here. So you know it is half base into height, and the intercepts becomes the base and height here. So it is half modulus AB, which is 24. And so modulus AB is 24 into 2, 48. AB is 48. I'm not taking the modulus values plus or minus because here 48 plus 48 because it lies in the first quadrant where both A and B will be positive. Now if AB is 48, I can take A to the other side so that B becomes 48 by A. And on substituting this equation 2 in equation 1, we get 3 by A plus A by 12 equal to 1. And on taking LCM and cross multiplication of this particular equation, we get the quadratic equation A square minus 12A plus 36 equal to 0. Now this is a quadratic equation which has equal roots. You can see that this is nothing but a minus 6 whole square. And so the value of a is 6. Now if the value of a is 6, if you substitute here a equal to 6, 48 by 6 will give us the 8 value. So here put a equal to 6 and b equal to 8. You will get x by 6 plus y by 8 is equal to 1. And on simplifying that, you will get the required equation of the line as 4x plus 3y plus 24 is equal to 24. So this is how you can solve the problems using the point of intersection. So my dear children, the homework for today is exercise 3C, where we have done the first problem. You will have to substitute these points in this line. By substituting the first one, you will get L11. By substituting the second one, we will get L22. and you compare. If both are of same sign, you say either side. If both are of opposite sign, you say they're on the same side, either side. So next one is finding the point of intersection. You can either use B1C2 minus B2C1 formula or simply solve these two lines using pair of linear equations which you have learnt in your 10th class. Now this is the theorem that you have seen for concurrence. And this is the problem already I have solved. You can go to the previous slide and see this is the problem that I have solved. And you have the other problems also here, for which examples are given before this exercise also. So you can slowly follow these slides and solve this. Also, you can go with the previous examples. Now, these are the problems in exercise 3C, which I expect you people to complete before we go with the next session. Yeah. So thank you very much to entire webinar team for giving me this opportunity to interact the students of our Telangana Model School. And over to Sridevina.
Thank you so much, ma'am. Really, students, you're fortunate. You're lucky to have Saishwari madam taking straight lines for you. I'm sure you will definitely solve problems on concurrency of straight lines, also intersection of straight lines. Stay tuned, students. After solving all the questions that madam has given you, please stay tuned for some more interesting sessions from ma'am so that you will learn when the lines will be parallel, what will be the condition for the lines to be perpendicular. All these will be dealt in your next session. Thank you, Saishwari madam, for taking out time and for giving such detailed explanation and helping our students. Thank you so much, ma'am.
Thank you, Saishwari ma'am. It was really a wonderful presentation, and the way you have solved all the problems and with a clear explanation, really students have benefited out of this. And children, do practice all the problems madam has given to you and revisit the site again and again, since mathematics needs practice. The only way to succeed in mathematics to get 100% result is doing, practicing, reviewing, and all. So thank you so much, ma'am. Once again, thank you.
Thank you.